Okay, so we're back at Desmos, and we were looking at how to graph equations of the form y equals mx plus b. We know that they create lines, and then we added this additional level of control where we can insert these curly brackets next to our equation, and we can restrict how much of our lines we're able to see with an upper boundary and a lower boundary. You could call the upper boundary U and the lower boundary L. This is sort of abstract looking, so don't worry too much about this notation at all. Let's look at the more concrete stuff. So we're going to take a look at the more concrete stuff, and we're going to get a little bit creative and playful with this. So let's say we want to graph just any old line, y equals 3 over 2x minus 2 or something. So here I have a line, and then let's say I want to be able to put in restrictions later, so I'll insert these curly brackets to the right. I don't know what I want these restrictions to be, but I know I'll want to place them on because I want to make a picture out of it. And then let's say I want some other line, right? So let's say I want y equals let's say I want y equals negative 1 over 2 times x plus 5 or something. So here I've got two lines, and we can notice that these two lines, they intersect at a certain point. And if you click around on this graph, Desmos will tell you where these lines intersect. Ultimately, in grade 10, what you're going to end up doing is you're going to be solving where these two lines could potentially intersect using algebra, solving linear systems of equations. But we won't go that far in grade 9, obviously. And I know I want to restrict the domain of this green line as well. I'm calling that the domain, but really we don't necessarily have that vocabulary in grade 9 yet, but that's really what it's called when we restrict the allowable x values for our graph. It's called restricting the domain. So let's say that when the blue line first crosses the green line, let's say I want my blue line to stop right there. If I want my blue line to stop right there, all I have to do is say that I only want to allow x values for my blue line that are less than 3.5, which is the x value where they cross. So I only want to allow x values that are less than, sorry, this is greater than. I only want to allow x values that are less than 3.5. So there you go. Now my blue line stops when it hits this green line. But let's also say that I want to stop my, let's say I'm following my green line up and to the left, following my green line up and to the left, following my green line up and to the left. But let's say I want to stop my green line where it intersects with my blue line. This will still be the same x value, but in this particular case, if I only want these values on the right, I can actually only allow x values for my green line that are larger than 3.5, right? If I restrict x values that are smaller than 3.5 for my green line, then I will get this sort of this peak that sort of points to the right, which is totally fine. But let's say that wasn't your intention. Let's say you wanted a peak that pointed up. So in that particular case, if you want a peak that points up, you will only allow x values to the right of where they cross. So you will only allow x values that are larger than 3.5. So 3.5 must be smaller than x, or x must be larger than 3.5. That would be the inequality that you write. And what that inequality tells Desmos is that you only want to allow x values that are larger than 3.5 for this green line. What do we have here now? We have, you could say, a mountain peak, right? If you want to be a little bit imaginative. You could even give them, if you click on this circle, you could even give them the same color. So we have this cool blue mountain peak. Now you can do that again and again and again with different lines. So let's say you want another mountain peak to the right of this, or to the left. Then you can just type in some other equation, y equals 2x plus 1. You can notice that this purple line, it doesn't really intersect where I want my other peak to be. So what you can do is you can shift this line down by giving it a smaller y-intercept. So what would be a smaller y-intercept than +1? Well, -1 would be a smaller y-intercept. You can see that that's clearly not low enough, so you can give it an even smaller y-intercept of, let's say, -5 or -6 or 7 or 8 or 9 or 10 or 15. This looks a bit better, maybe 18. I'm being picky here. So you can see that this because we have this element of control over where the y-intercept of this purple line is, we can place it more precisely. And now let's look where this purple line crosses this particular blue line. This purple line crosses this blue line at an x value of 9.2. That's what Desmos tells us if you start clicking around. And if you want to only allow x values for this particular line that are larger than 9.2, you can absolutely do that. So here I will introduce an inequality in these curly brackets. I only want to allow x values that are larger than 9.2. There you go. So now this particular purple line, it connects with this blue line, but it stops there, right? It stops at that intersection point. And let's say that for this blue line as well, let's say I want to stop this blue line at that intersection point as well. I can say, you know what, in addition, on this particular blue line, in addition to the x values being only larger than 3.5, I don't want them to be larger than 9.2. So let's say x also has to be smaller than 9.2. There you go. So these two, this blue line and this purple line, now connect and end where they connect, right? So this gives us a little bit more control over our picture. And then we can add one more line as well. So let's add maybe something like y equals 1/4 times, no, that's not a good enough of a slope. And I'm probably going to want a negative slope. So negative 2x. Let's say we want that as our line. And let's say I want this black line to intersect through this purple line. So if I want this black line to intersect through this purple line, what I can do is I can shift it up, right? So let's give it a y-intercept of something like 9 or 15 or still not large enough, 25. Hey, now they intersect. So here, this black line intersects with this purple line, and so I want to limit them from going up and to the left for infinity, down and to the right for infinity, and up and to the right for infinity. So I'm going to want to restrict the x values that I allow to be shown on this particular graph of these two lines. So let's say for the black line, I only want to allow x values down and to the right of this collision. I want to get rid of the x values up and to the left of this collision. So for this black line, I will only allow x values that are larger than this intersection point at 10.75. That's where they connect, right? This black line and this purple line connect at an x value of 10.75. So here, I only want to allow x values that are larger than 10.75. So there we go. I've restricted the domain for that black line. And let's say that I want to restrict the possible x values for this purple line so it just doesn't go up and to the right forever. So while we have this inequality already for this purple line where x has to be larger than 9.2. Let's say I don't want x to be larger. I don't want to allow x values that are larger than 10.75, which is where they intersect. So I'll say x, in addition to being larger than 9.2, has to be less than 10.75. So that's a little compound inequality there as well. And so here I have my two mountain peaks. I wouldn't say this is necessarily beautiful. This isn't an amazing mountain landscape, but I can at least change their colors so that they're all this nice, cool blue color. And maybe you don't like the idea of calling this a mountain landscape. Maybe you prefer the idea of calling this like the letter M or some sort of volcano or something. You can play around with the controls of Desmos as well. You can do reverse contrast if you like. But that is how you can start to be a little bit more creative and start making pictures out of Desmos, there are actually some pretty cool pictures that you can end up making as you get better and better with these graphs. And my Pre-Calculus 12 class, for example, just finished a project where some of the art they made actually floored me. It was so impressive. So if you get good at this and you get some element of control over how equations and inequalities can affect some sort of visual information, you can make pretty cool pictures.